Okay, so we're going to finish off lesson 8-2 on measures of variation with this example 1 here. So like I said, I saved us some time here, and I just started by organizing that list in order from least to greatest. So I'm just going to work through and find each of the measures of variation. So first off, I'm going to start by finding the range, which is your maximum minus your minimum, which once you have that list ordered, it makes it real nice and easy to see that we're just going to do 61 minus 3 to get us 58. Okay, up next are the quartiles. And before I can find the quartiles, I have to start by finding the median, which we now know is quartile number 2. So again, I'm going to use a highlighter to find my median here so that I can still see my numbers. So I cross 3 off and then 3 off. 1 and 1. And lo and behold, I've got 2 in the middle that I need to average. So 22 plus 29 divided by 2. Get your handy dandy calculator. 22 plus 29 gives you 51 divided by 2 is 25.5. So our median, or Q2, is 25.5. And that falls right in the middle of the 22 and the 29. That's what finding the average is. You're finding the middle of it. So that right there allows us to split our data into 2 equal parts. So then, for finding quartile 1 is going to require us to find the median of the lower half. So this is the lower half. And again, I'm going to switch to a different highlighter here to keep this organized, and I'm just going to find the median. Cross off 3, cross off 22, cross off, boom. I have a Q1 of 14. And then on the flip side, I'm going to do the same thing to find Q3. I'm just going to use the upper half instead of the lower half. And again, I'm going to switch colors in my highlighter because pretty colors make me happy, leaving me with a Q3 of 36. So now that I have all of the quartiles, I can use those quartiles to find my interquartile range, my IQR. IQR, if you remember, is taking Q3 and minusing Q1. So for us, that looks like 36 minus 14, which when you do 36 minus 14, you end up with an IQR, or an interquartile range, of 22. Just want to take a hot second and point out the way I'm labeling each of these numbers so I don't just have random 58, 14, 25.5, 36, and 22 floating around. I'm labeling these so I can see what they are. All right, last but not least, for this example number 1 here, we are going to calculate to see if there are any outliers. So I'm going to use those formulas right from above. And first, we got to check to see if there's any outliers on the upper side, if there's any larger outliers. So again, just copying down that formula. And now I know what these things are, so I can plug them in. Q3 was 36 plus 1.5 times the IQR we found to be 22. 1.5 times 22 is 33. 36 plus the 33 gives me 69. So are there any data values that are greater than 69? There are not. The largest one we get to is 61, so there are no outliers. No outliers because 61 is less than 69. Oops. If it was an outlier, it would need to be bigger than 69. That's what this says, greater than 69. But that's only the outlier on the low part. We also have to check the outlier. Sorry, that was the outlier on the high part. We have to check it on the low part to see if there is a number that is less than Q1 minus 1.5 times the IQR. Q1 we found to be 14. minus 1.5 times 22. We learned that to be 33. 14 minus 33 this time gives us negative 19. And again, there are no outliers on the low side because there's nothing less than negative 19. 3 is the smallest we have, and that's bigger than negative 19. So there are no outliers whatsoever. If I had had a number like negative 20 on my list, then that would be an outlier because negative 20 is less than negative 19. Happy mathing!